Hello everyone, in this video we're going to look at the homework, and so the first one, you can do the assignment exercise. Click Ctrl C, Ctrl V, and you can do StatCrunch, regression, linear regression. Choose variable 1 to compute. I give you intercept is 16.46 round to 1 decimal, so you go 60.4. Actually it's 5. I think he will accept it anyway. So 724. Okay, so that's estimate the final exam, final date, estimate the final examination grade for student. Okay, so get 88, so plug 88 in. 0.724 times 88 plus 16.4 is it 80.112, round 1 decimal, so it's 80.1. Okay, second question will be exactly the same, except you graph this function. It should not be a big problem for you to graph it. Okay, and number 3. Okay, there's a little bit change on this one. We can do new data. So basically you take the formula is lnz equals lncdw. So you take ln on both sides, you get lnz equals lnc plus lndw. Well, you can see this omega. But you can see that the y value, x value has not changed yet. X is still omega years. But the y value has been changed to lnz. So what we can do is copy that value into the StatCrunch and you do regression, linear regression, and 1 and 2, and then you do a transformation on y values, take ln on y, but x don't change. Then what you have is this is your lnc. So I'm looking for CD to omega. So this is lnc. lnc equals 8.78. lnc equals this number. So c equals exponential to this number. So e to 8.78. Okay, 6509. The next number is lnd equals negative 0.5. lnd equals this number. So d equals exponential function lnv exponential to this number. So exponential of this number is 0.9447. Okay. That's the only thing you need to pay attention. And the next one is evaluation s squared, the beta 0. So what you can do is that it's the same thing. Copy that, and you paste it into the new data table. And you can do that StatCrunch, linear regression, simple linear, x variable 2. And then you need a confidence interval on the beta 0, right? So click is 95 confidence. Alright, so now you got s squared is 0.42. The error is here, 0.42. And you got the beta 0, which is the intercept. So lower limit is 4.355. Upper limit is 8.6345. And beta is 1, lower limit is 3.395, upper limit is 3.186. Okay. So next one is going to be the same thing as the previous one. Number 6, and you have given the x and y. Okay, you have to do prediction values, and what you need to do, copy C and copy V. And start linear regression, simple linear, x, y, and then what you need to do, you do x 100 grams of water and 50 degrees. If you look at the table, the data, x is the degree, so x value is 50, and it asks you for 99% confidence interval. So you change that in 99, prediction value of y, right? Then you have your confidence interval is 37.12 for the mean response, and for the new value is 28.2. You just type in this 37, lower limit, upper limit, lower limit, upper limit, type it in, that's the answer. Okay, So number 7, you have to do some exercise, some work you need to do. So first, I need to do open the Excel. Open again. Okay, so in the Excel, there's the only thing I need to do, the beta 1 and beta 0, you can do that in the StatCrunch. That's no problem for you to do that in the StatCrunch, okay? So let's just open a new data table. And you can do click view, Control C, and Control V here, and style linear regression, simple linear, X and Y. There's no problem, you can do that. And then you have the least square, estimate B0 is 0.8 and negative 0.341, that's no problem. Null hypothesis, if the regression is linear or regression is non-linear. For the F distribution, the freedom is 3 and 20. Okay, it's 3 and 20. And because it's 5, subtract 2 is 3. And the regression error freedom is 23. 23 minus 3 is 20. Okay, so this F distribution value is the pure error. So it's lack of fit error divided by the pure error. So if you use 1.52 divided by 0.41, that's your error. So 1.52 divided by 3.68 will give you this number. Okay, this 3 is come from 5 minus 5 groups, 5 minus 2. Okay, you got 3 degree, and then 23 minus 3 equals 20. Then the only thing you don't know yet is this one. Okay, so the 3.1 you do, you click the view the F distribution. F distribution go 320, 320. You can see that 320 is 3.1. That's how you do this one. Now, how do you find a 4.5 and these two numbers? You need some calculations. This one you have to do add all the y square together. Okay, so this is the y values. I just open it from the data. I click it, open Excel. Okay, so you have to square all the y values. So equals the y value square. And you drag it down. You got 19. You can look at the summation of that is 1983.34. Okay, just make sure I got it right. Alright, I just do the sum of that. 1983.34. Okay, we got this one right. I put the sum, put it here. Alright, sum of the all y square. So next one is the sum of when x equals 0. What is the when x equals 0 have different y values. So when x equals 0, what is the sum of this one? It's 50.9. That's for x equals 0. X equals 2.3, 51.7. When x equals 4.5, all the y values is 4.5, 49.2. When x equals 9.1, 37.1. Okay. Then x equals 18.5, 22.1. This is the value. This because you only have 5 different x values. Now you have different y values of summation of that, and then you square this one equals. You square this this one. Oh, I have to divide it by 5 actually. We divide by 5 and then square. It saves it. No, I think it's square divided by 5. Okay, so equals this number, this y value square. Because I have 5 values, so divided by 5 is mean of, then it's pretty much very similar as previous one. Now I drag it down to here. So Now you got the square of this 5. Because this is just based on your square of the x, you got a y value sum and square and divided by 5. Okay, so that's going to be this is total regression error, and subtract this error, got to give you the pure error. I think let me see, 19098. Okay, 1909.832. Just double check again. 1909.83. Okay. So what do you have to do? What do you do the next? You subtract these two, subtract this two number, these two different y value, y square, give you 13.51, which is the pure error from just because of this different x values, give you this pure error. And the lack of fit is the total regression error. Subtract the pure error and give you this. So if you use 78.07, if you use 78, use the total error 0.07, subtract the pure error because of the different numbers have different y values, then you're going to get a lack of fit error, which is 4.56. So you have all these all of these numbers being filled here. This is easy, this is easy. This one you need to do a little bit of work here. So square all the y values, add them together, and add these x values together, add this x equals 0 y value, put it here, add this y value together, put it here, add this y values, put it here, and then square and square this divided by 5. Okay, square this number divided by 5 is here, square this number divided by 5, square this number divided by 5, square this divided by 5, square this divided by 5, and give you a total is this one. And subtract this 2 is going to be your pure error. And now what you do is the f values. F is 0.41. It depends on what f values they have. You compare the f with you compare this f with this value. This value is not bigger than 3.1, so we do not reject it. If we do not reject it, means not inside critical value. Okay, it's not inside it. If it's bigger than 3.1, is in the critical region, then we reject it. Because it's not bigger than 3.1, we don't reject it because it's not inside of the critical region. Okay. So point number 8 is the same as number 7. I look at this, it's pretty much exactly the same. Okay, you do the linear regression, you do the nonlinear regression. Okay, nonlinear regression, and you also have the same thing like the previous one. You have the data is the same, you all have the same values. Okay, and this f value is going to be 0.38 divided by 3.04, and which is the same 0.1125, and then this one you subtract it you divide, you subtract by 2 how many numbers you have. Okay, now 14 is to 12. Okay, and subtract by 2, subtract by 14, subtract the other one, whatever this number is. Okay, so you got the I think it's 14. Let me check. Let me open this. That's 5 groups, right? So now let me see how many groups here you have. So I just opened this from the StatCrunch. You can see you have actually 1, 2, 3, 4 groups. So you should put this one 2 here. And then, since this is 14, this is 2, and then I believe this one is going to be 12. Okay. Let me see. Total number is 1, 2, 3, 4. Just open it in this clip in StatCrunch, and let me do another one. Yeah, you see. Total is 16. 16 subtract 14 subtract 2. Yeah, okay, pure error is that. Okay, so next one you do this one based on exactly the same answer. What I did here, you add the 5, square all of this, which is equal all of them square, and you put them together, dragging it down, and then you add these 4 values, 47.2, put it here, and subtract, put the number here, and use that, subtract this, and give you this number. Okay. So it's the same idea as the previous one. You can do that by yourself. And next one is the R, the regression, the correlation. You check this one, copy it, and paste it, and you paste into here, and stat, sum across, correlation, and control, choose both, and you get this number is this one. And since this is not close to 1 or negative 1, so it's not close to the 1 or negative 1, so they don't have a strong linear relationship. Next one is the same thing as the previous one we did, and you just need to type in Control C, so this one, what you need to do, Control C, Control V, and then regression, simple linear. I think this one has a little bit change. Let me see. I need to see what is X, what is Y. Y is coarse grade. So Y is coarse grade. Y is this one. So just do Y values. Linear regression is the same. So Y is this one. X is this one. And you do 95, 35. Okay, so who made a 35 on placement test? So you got X equal 35 and 95, and it compute it. You got this is your lower limit, up limit for the mean response, lower limit, up limit for the new response. Okay. This one it is pretty much the same. You type. Okay, it's pretty much the same. It's just you read the values to the data. So, new data table. Okay, so what you need to do, copy this, Control C, and Control V here. Then you do stat regression, linear regression, and choose Y. I think this one you have to check it. Y is heart rate, and X is body. Let me see. Use heart rate is an independent variable. Heart is X, and Y is dependent variable. Y is variable 1. So I need to check that Y is variable 1, X is variable 2, and then two-tailed test, t-value. Okay, confidence interval. This one, and it doesn't ask me for confidence interval, so I just do this and compute. You got this is the intercept, this is slope, and also the t-value for beta 1. Beta 1 is a slope. So slope, I have a t-value. Slope t-value is negative 0.44, is right here, and it's two-tailed test because it's not equal two-tailed test. P-value is 0.66. P-value is 0.66. Do not reject it because P is bigger than 0.01. I think this is P is big. Actually, 0.66 is big. So it means we reject it. Reject the long hypothesis. Do not reject. Do not reject. This one means beta 1 not equal 0. If beta 1 not equal 0 means it has a linear relationship. So there is a linear relationship. Okay. Okay, number 12, you basically is the same idea. You do R, and then this is R square. Okay, R, you know how to find R, right? You just do the same thing as the previous correlation, and control, and copy, and then Control C, Control V, and find the linear tables, summary exact correlation, and choose the second two, and you got the correlation is 0.9, and square that is the ratio. Is the linear ratio, and square this is square 0.9 is 0.81, is 81%. Y and X random variables, and this one is not big problem. And you test if the row equals 0.5 or row is bigger than 0.5. That's what it says here. And it's one tail on the right tail test. And you need to find a z-score. Okay, z-score is 2.77. Z-score is based on one formula. The formula is square root of n minus 2. I think the formula is square root of n minus 3 over 2 ln. You double check the formula. I has a formula. You can find this formula in the book, the z-score, and if you can go help me view example, it has the formula to find the z-score. You just need to plug the R and the rho into the formula. You should be able to find a z-score. Once you find a z-score, you type in the z-score, use the formula given the book, or give you a view example. You should be able to get the formula. Once you got a formula for the z-score, you just do the sum calculator, and this one actually tells you if you do 2.77, 2.77, and you choose bigger than, and this is your p-value. 0.0003 rejected because the p is low. The null hypothesis must go. Next one is going to be is pretty simple, and consider fitting that right where the lines to the fitting line regression schedule residue plot, and this one is nothing very difficult. Okay, so on the project, remember in the project there's one thing you need to do. I would like to introduce how to use the StatCrunch to do it. The problem A, project problem A, which is pretty simple, plot it, right? Plot it. Let's just do, let me see if this one has a graphic. Let me see if it has a, let me choose it, see if it has a strong linear relationship or not. Okay, this one is not bad, so it has a relationship. So what do you need to do? First, you just plot it, right? Plot, you can graph it. You can graph x and y. This one give you x, y, or you can graph. This one can give you graph x and y by pie chart, qplot, mean plot, dot plot, box plot, scatter plot. You can do. I think you can do this. Do V and do 3, whatever number you got, you can compute it and it give you this. You can compute this, or another way you can do a regression, simple linear regression. Choose x, choose y, and then you graphs right here. Graphs featurely line plot, and also give you the graph right here. Okay, and then you can what you can do. I think you can copy. I'm not sure how you can copy. I think there should be a copy. You can copy the graph, and then you paste in your word, you should have this graph. Okay, so that's the first one. Second one, filter appropriate regression from the data. Then this is just a simple linear regression. Give you a model which is y equals beta 0 plus beta 1x, 16.33 plus 1.12x, for example this one, and then common measure of the quality, and find this is the error. And you can look at this book, look at your book, and see if you have. Okay, so this is good linear correlation because p-value is really small. Okay, so the model is good for this one. Number 3, plot the residue as illustrated in text. Check possible violations assumptions. You can do beta 0, beta 1. You can do assumption right here, right? Beta 0, beta 1. You can check if it's 0. You can look at this. You see alternative and p-value both. This is less than 0, so reject null hypothesis. There is a slope. There is a slope. There is a linear relationship. How about the beta? Beta would reject null hypothesis. The beta is not 0. Okay, so beta. Okay, so now beta 0. The estimate of this one actually is not 0. Okay, so now what we'll do for next one, plot the show that graphical plot of confidence interval mean response. This one I need to tell you how to do it. What you need to do, you have to copy prediction of y values. Okay, basically you just need to copy. Okay, you just copy all this. Suppose this is the x value. Copy it. And then you added it and put all your x values here, copy this one here, and then when you plot it, you press control, choose with mean interval. So you can compute it, and the next one you can see the green one is 95 up confidence limit on mean response, lower limit on mean response. This is what I ask for. Okay, on mean response, plot against the x values. Okay, you can graph more, plot more pictures with this, and you can do more comment, You can do predict more. You can also do prediction values with the plot. Either you can do that. Okay, so this is the instruction about the number C. Okay, you can plot more pictures and comment how your model is, how your data is. So based on your subject, you choose. Okay, that's the project to the plot C if you still have question. That's all the instruction of the homework. Thank you very much.